Welcome to day 2 of our course on AI and generative AI. I'm Dr. Muhammad Abdul Mateen, and today's focus is on machine learning and data in action. We'll explore what machine learning is, understand different types of learning, and look at real-world applications. We'll also take a deep dive into prompt engineering, an essential tool when working with generative AI, and wrap up with a hands-on activity. Introduction to machine learning. Let's start with the basics. Machine learning, or ML, is a subset of artificial intelligence that enables systems to learn from data and improve over time without being explicitly programmed. There are 3 main types of machine learning. Supervised learning, where models learn from labeled data. Unsupervised learning, where the system identifies patterns in unlabeled data. And reinforcement learning, where agents learn by trial and error through interaction with an environment. Each of these approaches has its own strengths and use cases, which we'll explore next. Supervised learning. Supervised learning is the most widely used ML method. It involves training a model on a dataset that includes both input features and known output labels. The goal is for the model to learn the mapping from inputs to outputs, so it can predict the correct label for new data. Examples include predicting housing prices based on features like location and size, classifying whether an email is spam or not, recognizing digits in handwritten images. With a large, high-quality dataset, supervised learning can deliver highly accurate results. Unsupervised learning. Next, we have unsupervised learning. This method is used when the dataset has no labels. The goal is to discover hidden patterns or groupings in the data. One popular application is clustering, like grouping customers based on their shopping behavior. Another is anomaly detection, such as identifying fraudulent transactions. Unsupervised learning is all about exploring data and uncovering insights you didn't know were there. Reinforcement learning. Reinforcement learning is a dynamic learning method based on rewards. Here, an agent takes actions in an environment and learns from feedback, either reward or penalty. Over time, it figures out which actions yield the highest long-term reward. This approach is used in areas like robotics for motion control, game AI like AlphaGo, and even self-driving cars, where learning through interaction is critical. It's a powerful method for solving complex, sequential decision-making problems. Real-world applications of ML. Machine learning is being used across almost every industry today. In healthcare, it helps diagnose diseases from X-rays and scans. In finance, it predicts credit risk and detects fraud. Retailers use ML to personalize shopping experiences. And in transportation, it powers autonomous vehicles and route optimization. Simply put, ML takes data and turns it into action. Prompt engineering, better input, better output. As we shift toward generative AI, a key new skill emerges: prompt engineering. Prompt engineering is the practice of writing clear, structured prompts to guide language models like ChatGPT. The golden rule? Better input, better output. Effective prompts have 3 parts, known as the RTF structure. Role: what persona should the AI take? A teacher, a marketer, a coder? Task: what should the AI do? Provide tips, write code, summarize a report? Format: how should the answer be structured? Bullet points, a table, or a concise paragraph. With practice, you'll find this structure dramatically improves the quality of AI responses. The 5S framework for prompts. To go even further, use the 5 S's for crafting effective prompts. 1. Set the scene. Provide context so the model knows the situation. 2. Specify details. Be precise in what you ask. 3. Simplify language. Use plain, direct instructions. 4. Structure the output. Ask for clear formats, tables, lists, headings. 5. Share feedback. Refine the prompt based on the results you get. Think of prompt engineering as a conversation. The clearer you are, the better the model performs.